How you doing? My name is Mr. Donovan. So this first example, we're going to look at how to graph a system of inequalities. Then that will give us a feasible region. And in that region, we're going to try to find out what coordinates or what solutions to that region give us the maximum and minimum values. So here's my system of inequalities right here. And so if I made a quick sketch of that, I'm just going to show you my y value has to be between -3 and 5. So if I were to make a quick sketch of that, 1, 2, 3, 4, 5, I would have a horizontal line at y equals 5. And 1, 2, 3, 4, actually I don't have to go down that far, down to -3, I have another horizontal line. And so y has to be between those values right there. And my next equation is y less than or equal to 4/3 x plus 8. So if I extended my y-axis, I've got 1, 2, 3, 4, 5, 6, 7, 8. The y-intercept is 8. And then if my slope were 4/3, then I would go down 4 and to the left 3. 1, 2, 3, 4. 1, 2, 3. And down 4 again. Onto the x-axis, 1, 2, 3, and then down 4, 1, 2, 3, 4, and over 3 more. I get this line right here, and that is less than, so I'd be shading below that line. And then my last one is y less than or equal to -2x plus 2. So my y-intercept is +2, and my slope is -2. So I go down 2 over 1, down 2 over 1, down 2 over 1, and I get something that looks like this. Okay, and the solutions for that one are below that. So my feasible region then is this area right here. And what I want to do is I want to find the vertices of this region. Now, mind you, this is just a rough sketch. I'm going to show you how you can do this using an application called Desmos. And it's just easier to find those vertices. Those vertices I'm then going to test in this function and just observe which one gives me the maximum and which gives me the minimum. So I'm going to switch to Desmos, and I'm going to type in -3 less than or equal to y, which is less than or equal to 5. And you can see it automatically graphs that region. And then I touch right below that and create a new box. And my second inequality was y less than or equal to 4 divided by 3 x plus 8. And I can move and drag this around. And then my last one was y less than or equal to -2x plus 2. And so I can see I did get a triangular region. Actually, no, it's not a triangular region. I wasn't very accurate with it's a trapezoid. So if I went back to this, I'm going to undo this for a second, these points. And I'm going to emphasize that right here, this is actually, I've got 2 points. This is a trapezoid. Okay? So what I'm going to do is I'm going to number these vertices, and I'm going to consider my Desmos version of this to be more reliable than what I did just by making a sketch. So looking at Desmos here, I can just touch that point and it will give me negative 2.255. So I'm going to write negative 2.255. And then my next corner vertex, sometimes I call them quarter points, is negative 1.55. And then my third vertex is negative 0.53. And then lastly, my other one is negative 3.753. Okay, so then what I'm going to do is I'm going to plug those into this f of xy function and see what I get. So when I plug in negative 2.25 times negative 2, that would give me 4.5 minus 5 times 5, which would be 4.5 minus 5, which is negative 20.5. Okay, and then the next one, negative 2 times negative 1.5 would be 3, and 3 minus 5 would give me negative 22. And then when I plug in negative 1/2, 3, negative 0.5 times negative 2 is 1. And 5 times 3 is 15, so 1 minus 15 is negative 14. And then lastly, negative 2 times the negative 3.75 would be 7.5. 7.5 minus 15 would be negative 7.5. So my maximum value is actually the negative 7.5. These are all negative. So I would circle this. This is where my maximum happens. And my minimum value is the negative 22. So I'd circle that. That's my minimum. Okay? This is a really good way to find maximum and minimum quantities if you have two variables to deal with, to contend with. So we'll look at some word problems where they apply to two variable systems, and we'll do the exact same process. Thanks a lot.